Alright, Geometry, we're back with your favorite TV series. It's called Chapter 9 of WMAA Honors Geometry, and here it is. So we're going to start with going over the distance formula, which I talked about in the module, and I said how it was something that we should be familiar with. Maybe we don't know anything about this formula right here, but we sure can rearrange it so that we can understand it more. So just to go over this real quick, we've seen this before in the Pythagorean theorem, because if this is our algebraic equation, what can we do to this side and this side to simplify? Well, what we can do is square both sides. So if we square both sides, we end up with d squared equals y1 minus y2 squared plus x1 minus x2. And sorry, when I started the video, I had forgotten the squared above the y1 minus y2 and the x1 minus x2. So what we have now is d squared equals y1 minus y2 squared plus x1 minus x2 squared. So what if we said that this equals A and this equals B? Well, then we literally have the Pythagorean theorem. So throughout this chapter, if you start to get stuck on memorizing the distance formula, don't worry about that. You know how to do the Pythagorean theorem, and we're going to show you when and how to apply that. And this is just the form that it takes when we're given 2 points instead of 2 side lengths. And so we'll talk about how to find those side lengths given the points, like this. And so we can use the coordinate plane and the Pythagorean theorem and the distance formula to find area and perimeter. So let's go ahead with this next example. I just wanted to show you how the distance formula relates to the Pythagorean theorem. So we'll go ahead and we will plot our points here. So we have k at -2, 4. We have L at 6, -2. We've got M at 4, -4. And we've got N at -6, -2. So we'll go ahead and connect all these points. These will be the vertices where 2 lines intersect. I'm trying to draw them nice and straight, nice and good. So we're going to retry that one. That was pretty good. That was pretty good. That could have been better. That was good. Okay, so here's our object. Here's our figure. And our task is to find the area of this polygon. Okay, so I mean, we all know the formula for these shapes, right? No, we don't know the formula for these shapes, but that's okay because all we have to do is split this up into pieces that we do know. So a spot where I see that we can split this into pieces that we know is going to be either on a horizontal plane or vertical plane, so that I can try and count those units, because that would make it so much easier to just count the units of one measurement rather than calculating them all, right? And so with this figure, somewhere where I see a horizontal line that can be drawn between 2 vertices is between, sorry, I'll label these quick. A horizontal line can be drawn between N and L. So if we draw that horizontal line right there, we can go ahead and we can just count these units up, right? And that'll give us our base measurement for 2 different triangles. And once we find the area of these 2 different triangles, we know that we have the area of the whole thing. So up here I'm going to write area of K, L, M, N equals the area area of triangle LNM plus the area of triangle KNL. So this is just me describing mathematically what I'm going to be doing to find the area of this figure, and I'm just saying that I'm going to add the area of this figure and the area of this figure. So what we got to do, first of all, we can find the measurement of this base here. And how can we do that? Well, since it's a horizontal line, like I said, we can go ahead and just count these units. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got 12 units. So ln equals 12. And so in both triangles, triangle LNM, triangle KNL, the area is going to be 1/2 base times height, right? So we know that we're going to have 1/2, 1/2, and we just found our base. Our base can be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? That one was pretty simple to find. And that goes for both of them, because this base is in both spots. And then let's look at our heights now. So luckily, our heights are perfect units as well. So we see that LNM has a height of 2, and KNL has a height of 1, 2, 3, 4, 5, 6. And so we can find the sum of this and add them up, and we'll find that 1/2 times 12 is 6, 6 times 2 is 12. 1/2 times 12 is 6, 6 times 6 is 36. We'll add those products up to find the area of the entire figure, and we will find that the area of KLMN is equal to 48. And we're always going to put our units on there. So right now we're just going to do units squared. So in class we're going to talk a little bit more about the distance formula. We don't use it too much in this one. We're going to use the distance formula a lot more when we find perimeter, because perimeter is going to be adding up all of these sides, and the only way to find these sides is by using that distance formula. So I'm going to show you how to use the distance formula quick. So let's say that we have to find the length of Kn. This just stands for length. I don't think that's how we're going to denote it in this class, but that's all that stands for right now. So we're finding the length of Kn. So if we want Kn, our 2 points that we're working with, obviously, are going to be K and N. So we've got K, -2, 4. And we've got N, which is -6, -2. And so this is where this becomes a Pythagorean theorem. So what your x and y coordinates are really telling you is just the location of the points, right? And so what the distance formula does is it takes the difference of those points, so it measures the vertical difference and the horizontal difference, it squares them, and that way we can find the hypotenuse. So let's draw a little right triangle here. Right? Here's our right angle. Here's our hypotenuse. Here's one side length. Here's another side length. So let's try the distance formula again. So we've got D equals the square root of, it was y2 minus y1 squared plus x2 minus x1 squared. And like I said, if that's hard to memorize, that's cool. It's just the Pythagorean theorem. Because how do we find the horizontal distance from N to K? Well, we can subtract k from n, right? The x values, because x is horizontal. So if we subtract k from n, we're going to get what? Negative 6 minus negative 2. So negative 6 plus 2, that's going to end up giving us negative 4. And can distances be negative? And this is where the class goes, no, distances cannot be negative, just like magnitudes, right? So we know that this length is going to be 4. And look at that. That formula, right, going negative 6 minus negative 2, gave us the same number as if we were to just count these units. And so that's how the distance formula works. It really just turns this line into a hypotenuse, and it finds the side lengths from the coordinates of the points and uses those side lengths to find the hypotenuse, which is the original line's length. So let's keep it going. For the y values, we know that we're going to get 1, 2, 3, 4, 5, 6. 6 is going to be our total, and the way we get that is going subtracting in the same order. So if we went n minus k for x, we're going to do n minus k for y. So we did do n minus k, so we're going to do negative 2 minus 4, and square that. And so we end up getting, like I said, 6. So we get negative 6 squared plus 4 squared. And we'll simplify that out a little more. We get 36 plus 16, which ends up being the square root of 52. And so we can put the square root of 52 into simplest radical form, but frankly, for this example, I just wanted to show you how to use the distance formula. And so this is that right there. And so if we were to find the perimeter of this figure, we would use the distance formula for not only this side, but also this side, and this side. So that's 9.4, finding the perimeter and area in the coordinate plane. We will cover this more in class as a group, but I hope that y'all have a decent grasp on it now, and we will talk soon.